This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
So, what are you guys discovering about tornadoes and convective storm effects, especially as you're kind of learning from these dust devils? And what are some things that we can do to mitigate damage from these storms?
Yeah, that's a good question. Yeah, I'll bring it back to dust devils first. I mean, I think that the data collected from this has a lot of applicability towards tornadoes. Some of the characteristics here can be used to better understand what's going on in tornado simulators, for example, or computational simulations to see, hey, are we getting realistic effects here? And those things can be used, more broadly to mitigate tornado effects. But I think similar to dust devils, I think we're finding out we need to find out more about what's going on. I think, in general, I think we're realizing that tornadoes, ASC 722 now has tornado design for the first time for category 3 and 4 structures, which are high occupancy structures, not residences, but potentially higher risk structures if something were to happen. And so it's important that we find out more. I think we realize we don't know as much as we'd like. And so there's a lot of good work going on right now in the experimental and computational domains with respect to tornadoes. And it's really showing a lot of the same things that, the wind characteristics and the wind loading for these tornadoes are significantly different. But again, questions remain on how applicable the data is to real tornadoes, and, can we extend what we're learning there to the damage and destruction that's caused? And, the challenges, I mentioned it earlier, is really that the field measurements are really difficult to capture and dangerous on some level in enough detail to really utilize them on the engineering side. And so another way that some of us learn, including our group, is through, post-damage surveys. You learn a lot, right? So you probably don't have measurements on any tornadoes right near the ground, which we really need it. And if we do, it's a really, really small percentage. So, we learn a lot from post-damage surveys, things like STEER, help us go out and try to investigate some of the damages, or, both to the natural and built environment. So one of the things that we would go out and do is, we would look at patterns of tree fall in tornadoes, or things like even crops, which show the tornado wind flow really, really clearly. If things get damaged, we can learn a lot about the wind characteristics that way. And then, of course, the structural damage, you go out and you can learn about, just how structures respond to tornadoes, the overall damage profile, things like debris, how much impact does that have as it, that would, like, say, leave a structure and go downstream and potentially impact other structures. And we've kind of known that for a while, but I think, at least in my experience, every time I go out and do one of these surveys, you think you go out and you have a good understanding of what happens in a tornado and the damages caused, but there's always things that just, confound you when you go out there, especially when you're looking at a neighborhood or suburban area or urban area. You see some of the damages and you're thinking, I don't know how this exactly happened. It'd be great to be able to try to recreate that. That's where the experiments, tornado simulators like at Texas Tech and Iowa State can come into play, and the computational simulations as well, to help us better understand what we're seeing on the ground. Because there's always some really interesting stuff that you see and you can't really piece it together. And things like even like surveillance cameras and things are really kind of generating some insight about, there's some strange things going on here. I can't quite make sense of it. How does it happen exactly? So I think we have a lot more to learn, and it's becoming more important. I think we're realizing that tornadoes really present bigger risks than we'd previously thought. I mean, I think all the steps in research and practice in that direction pretty much tell us that. And so, yeah, I think it's still open for, there's a lot of stuff going on in the tornado space. There's a lot of room for discovery there. Yeah. Oh, you asked about mitigation too. Yeah. So I think some basic mitigation techniques can always help. I think we still, trying to minimize the potential amount of debris or openings to your structure, way to protect windows, way to protect your garage door, things like that. The loading can be significantly magnified if you allow, wind to get inside your structure. And those things those things have been known for a while, but those are simple mitigation techniques that would certainly reduce your risk and level of damage to tornadoes. And there's people looking at that, but I think too, on the research side, there's a struggle to understand the wind loading and wind characteristics a little bit better to, better inform how to mitigate these things.
Yeah, it makes sense because tornadoes are inherently harder to study than something like hurricanes, where they're big, they come over the course of many days, they're relatively more straight line winds, so something like a wind tunnel like we have down at Florida or at the Wall of Wind at FIU can fairly accurately approximate wind loading from a hurricane. And so design codes and building codes in places that are affected by hurricanes are way ahead of the wind loading codes of places that are more prone to tornadoes, like Kansas, Oklahoma, Illinois, Missouri, places like that.
Yeah, that's a really good point. I think that's a challenge right now is trying to figure out the best ways to simulate these things.
It's a really good segue to our next topic, right?
Sure.
So under the NARI network, those who have been following along with us for a little while, the National Science Foundation has just put their money where their mouth is, literally, and have funded the design so far of a new multi-million-dollar, so like a mid-scale level facility that's looking at not just wind hazards, not just wave hazards, but both. This multi-hazard research facility called NICHE, which I won't pretend to explain the acronym because it's long, but you're a co-principal investigator on that, which is really exciting. You guys are in the planning phase, the kind of working through the design. So NICHE is in the design phase. You guys are still kind of wrestling with some fundamental questions about if we were to have a facility that was built with all the capabilities that we wanted, what would we be able to do? What are some of those big research questions that we would be able to answer that we can't right now? Like we have big wind tunnels, we have a big wave tank. We don't have anything that combines the two. And even in the wind tunnels, it's hard to simulate the kinds of wind loading that you're interested in as a wind engineer in the tornado and dust devil and derecho space.
Yeah, great points. And I think, so I think that's the first thing you mentioned is the kind of the key element of NICHE is trying to combine, really the extremes of wind and water together, right? There are facilities that do wind, facilities like IBHS. There are facilities like UC San Diego, Sustain, other facilities that do water, Oregon State. But nothing together, right? And so nothing to be able to bring that space together where the really extreme events occur, right? And so for hurricanes, things like climate change may exacerbate some of these things, and we really need to kind of understand how these effects work in tandem. And so that's one of the major things that's going on.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NARI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NARI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.